Today we're going to look at 12.4, the law of cosines. So we've already talked about law of sines. You know your basic trig functions. We're going to look at law of cosines. So when we have a law of sines, that works when we have a pair. So when I don't have a pair, if I don't have an angle and side opposite each other, then I can't use the law of sines, and instead I need to use the law of cosines. The law of cosines will work when I only have one angle and I don't have the side opposite that particular angle. Or if I have all three sides and I need to find an angle. So here's what the law of cosine says right here. A squared equals b squared plus c squared minus 2bc times the cosine of A. Remember that your lowercase letters are side lengths. Okay, so these are sides right here. Okay. And A is one of your angles. Now this also works if I have, say, angle B or angle C. I just have to adjust my letters accordingly, and I'm going to show you all three versions on the next page. If you want to know where this comes from, there is a way to derive where it comes from using some triangles, but it takes a little while to explain, so we're going to skip that part, and right now I'm just going to say, trust me on the formula here, memorize it, use it over and over to get you familiar with it. Once you're used to it, once you have memorized, it's just plug and go. So we're going to go ahead and jump right into our very first example here. Given angle C is 60 degrees, side A is 10, and side B is 14, I want to find the rest of my parts. Okay. Notice in the box here on the right, the law of cosines is listed in all three possible ways. Depending on what angle I'm going to have to use or find, I have three different versions. Notice that the angle I'm using is the same as the side that I start with on the left. So if I'm using angle A, I use A squared first. If I'm using angle B, B squared, C, C squared. Okay. The other two parts, so if I'm using angle A, then the other two sides, B and C, are going to be the two that I use in that middle section. Okay. You'll notice that it starts off looking kind of like Pythagorean theorem. So this first section here looks kind of like Pythagorean theorem. The C squared equals A squared plus B squared, or A squared equals B squared plus C squared, or whatever the version is. It looks sort of like Pythagorean theorem, except we know we don't have a right triangle, so it's not Pythagorean theorem. And then I have this kind of, I think of it as like the modification to the Pythagorean theorem. Minus 2ab, so minus 2 times these two parts here, times the cosine of the angle in between those two sides. Okay? It just takes some getting used to be totally honest with you. I'm going to erase all those marks. It just takes some getting used to how it works and what it looks like. It's just another weird formula that you have to know how to use, write it over and over again, memorize it, and be able to plug things in. Okay? There's not really a great way to explain it except for that. Just memorize it and learn how to use it. So I'm going to use this example here. Angle C is 60, side A is 10, and side B is 14. So I have a picture down here that I'm going to label those parts on. So I'm going to kind of scroll down here a little bit and put my 60-degree angle here. A is 10 and B is 14. So you'll notice that if I just take the parts I have, I don't have a pair. Remember, law of sines needs a pair. I don't have a pair of angle and side opposite each other. And I can't find my other two angles because I only have one, so these two could be all kinds of things. And with these two sides and not having a right triangle, there's no way for me to find that third side right now either. So instead I have to use this law of cosines. So in order to use law of cosines here, I first need to figure out which version of it I'm looking for. And because I have angle C, and I'm going to use angle C, then I'm going to use that third one in my box here, this last one here, because it has angle C in it. Okay? And so I'm going to use C squared equals A squared plus B squared minus 2AB cosine C. and I'm going to plug in the values that I have. I don't know side C, so that's going to be my unknown. I know A is 10. I know B is 14. And so I'm going to plug both of those into these two spots where they show up. Almost forgot my 2. And then the cosine of my 60-degree angle. Okay. So when I do what I know here, I know 10 squared is 100, 14 squared is 196, 2 times 10 times 14 is 280, cosine 60. I don't know that. I know that off the top of my head. You probably don't, and you haven't learned that yet, so we won't plug that in. And so what I can do here, just remember your order of operations. This is a common mistake that people make, and that is the want to add these 3 together right here. However, notice this is addition, subtraction, multiplication. Okay, so I can't add all 3 of these together, but I can add these 2 together. Okay, so we could keep simplifying here. 296 minus 280 cosine 60. And the reason I would want to do that is because it just makes it a little bit easier to plug into my calculator. Okay, notice everything here on the right side can be plugged into a calculator, so go ahead and do that. Pick up your calculator, plug all that in all at once. And if you do that, you're going to get c squared equals 156. Kind of nice how that turns out really even. Okay. And then, of course, that's c squared. So c equals the square root of 156. If your teacher is looking for an exact answer, you would leave it. But remember, we're going to have to use that to find the other parts of my triangle. And so we're going to need to get a decimal for that. 12.5 approximately. So it's about 12.5. And so that gives me this one part of my triangle, 12.5. 12.5. So once we get that one part of my triangle, notice what I have. I now have a pair, opposite angle and side. So the note here in the middle of my page that says, once I use the law of cosines one time, I'll be able to use the law of sines. Because now I have a pair, so now I can set up my ratio of law of sines. The sine of 60 over 12.5 equals sine, pick a different angle, we're going to go with A, over side A, 10. Now you will notice that we have to use this rounded answer here, okay? If you don't like to use that rounded answer, we could instead write this as the square root of 156, right? Because that's where it came from, right here. Okay. Sometimes you're going to have that option. There are going to be other times when this value here doesn't come out to be a nice whole number like 156. And so your calculator is just going to have decimals that you have no control over being able to use. This is the one of the very few exceptions where using a rounded answer, using an answer that you have found from a rounded number, is acceptable. Okay? Most of the time we stay away from using those rounded numbers because they're not exact, so we want to make sure we are as accurate as possible. But in this case, we really have no choice. We are going to have to use that rounded answer there. Okay? And so I can use that rounded answer, or in, like I said, in this particular case, I could use square root of 156 in my calculator. Either way, when we work through our law of sines here, which you can look at in the other video, I'm not going to take the time to write it all out. When you cross multiply, take the inverse sign, and you solve for A, we get that A equals approximately 43.9. And again, check with your teacher as to how they want you to round that answer. So 43.9 is angle A. And then we can keep making our life a little bit easier. 180 minus 60 minus 43.9 is going to give me my angle B, 76.1. And so that gives me angle B. So as you get more information, things become a little bit easier to solve, right? Law of cosines takes a little while. You got to plug a lot of stuff in. Once you get that, law of sines, a little bit easier. You can use that. And then, in this case, even easier, subtract from 180 to find our third angle. Okay? And so that's how law of cosines works. Okay? Law of cosines is really good because not only can you use it in situations like this, where you have two sides and the angle in between them and no pair, but we can also use it when I have all three sides. Okay? In this case, since I have all three sides and I'm missing an angle, it doesn't matter which version of the law of cosines I use to start with. Okay? Remember, we have the three different versions here with the three different angles in them. And so you can pick whichever one you feel like using, and you can use that one. So I'm just going to use the first one there, the a squared version. So if I do that, then I'm going to have this one as my formula. Let me go ahead and write it out so I don't forget any of the parts. Okay. And then I plug in what I have, which is 43 for A, 39 for B, 59 for C, plug in B and C again, cosine A. Now again, this takes a little bit of manipulating here, and please use your calculator. Those are some big numbers. So if I work this out a little bit, I end up with 1849 equals, remember I'm going to do these two squared. I'm going to go ahead and add those two together because I can. 5002 minus, and then I'm going to multiply these, and I get 4602 cosine A. And then here's where we have to kind of be a little tricky. Okay? Think of this cosine A as your variable. If I'm going to get that by itself, I need to subtract 5002 and then divide by negative 4602, right, in order to get rid of that. So you're going to have to do a couple steps there in your calculator. I already have that done for myself, and I get 0.685 equals cosine A. Okay, make sure you do all these steps in this order. You're going to have to take a little bit of time to do all these. Then to get A by itself, we have to do the inverse cosine of that 0.685. Okay, and again, that's rounded. If you get that value in your calculator, that whole decimal, leave the entire thing with all the decimal places in your calculator and use that little ANS, that answer button in your calculator, so that you can use that whole decimal. And that gives us that A is approximately 46.8. And now that I have A, I can use my pair here, A and angle A, okay, and I can set up my law of sines to solve for the other two. So if you want to do that, go ahead and pause the video and take a minute to do that. And the answers are 41.4 degrees and 91.8 degrees. If you're off just like a decimal or two, that's fine. Depending on your calculator and how you plug things in, you might be off by a couple decimal places. And that's fine. Just remember, always show your work and you'll be good. Okay? And that's law of cosines. So know how to plug things in, know how to solve for the parts you need, and once you do that once, you can go back to the other parts that we know because you'll have a pair.